Hello, how are you doing? This is Mike again, and we are going to continue on with our radical equation solving video series. And in this problem, we're going to advance our difficulty slightly. So notice here we've discussed some properties already, and we recognize that we have a radical. So whenever we have a radical, we're going to have a domain issue. So as I said, you have two different options to either determine the domain at the very beginning or to make sure that you plug in your answer at the very end. But I'm going to do both for this one to see how it pans out. So in this circumstance, we have a square root. So square root, which is the index, even though we don't see it. So we know that's going to be a value. The domain is going to be 7 minus x must be greater than or equal to 0. So we add x on both sides, and we get 7 must be greater than or equal to x, which implies that x must be less than or equal to a value of 7. So either one of those suffices, each one of those, are similar. As long as our answer suffices this criterion, then we know we have a good, correct solution. So now in order for us to solve this radical equation, we're going to have to perform the opposite operation of the square root, which is in fact raising it to the second power. So we're going to raise square root of 7 minus x to the second power, but whatever I do on the left side, I'm going to have to do on the right side. So the square root and the square will cancel, and we're going to be left with 7 minus x equals to a value of positive 4. I'm going to subtract 7 on both sides. So on my left side, the 7 and the negative 7 will cancel, and I get negative x equals to a value of negative 3. And I'm going to divide both sides by negative 1, and this will determine your solution, and we get x equals to a value of positive 3. You can look at your domain and say, yes, that's sufficient because 3 is less than or equal to positive 7, so you are okay there. But for me, I always like to check my answer with these because sometimes I read the inequalities wrong. So I'm going to plug in just to make sure I get that 100% full credit on those exams. So I'm going to have the square root of 7 minus 3, which is the square root of 4, and that equals to 2. So notice that works as well. So we checked it two different ways. Again, we're performing the same operations. We have the radical isolated on one side. We perform the operation that is opposite of that root, and whatever we do to one side, we do to the next. Let us go ahead and continue with this example. So this one's slightly different because we don't have the radical completely isolated. You could, if you wanted to, square one side and square the other, but if I did that the way it stood, I'd have to FOIL out the left side. And I don't want to FOIL out the left side, and we'll do an example coming up with that. So the first thing that I want to make sure to do is to isolate the radical. So we want to isolate the radical as much as you possibly can. So I can subtract 2 on both sides. So this gives me the square root of b minus 3 is equal to a value of 3. So I've isolated the radical as much as I possibly can, and I got those constants on the same side together. And now the opposite of the square root again, because this index is a 2, even though we don't see it, is 2 raised to the second power. But whatever I do on the left side, I must do on the right side. So the square root and the square cancel, and I'm left with b minus 3 equals to a value of positive 9. And I add 3 on both sides, and I get b is equal to a value of positive 12. So notice I didn't state the domain of this problem at the very beginning because I always like to plug in. You could have recognized that b minus 3 must be greater than or equal to 0. Solving, you would get b being greater than or equal to 3. So it's sufficient based off of that criteria, but sometimes when I get multiple terms, identifying the domain may not be quick. So I'm always going to plug in just to make sure I'm correct. So I'm going to get the square root of 12 minus 3, still plus 2. The square root of 12 minus 3 is going to be the square root of 9 plus 2. Square root of 9 is 3. 3 plus 2 is equal to 5, and that's what we suspected our final solution to be. Moving on down to our next problem in this video series is the square root of y minus 5. And again, the instructions for these will always state to solve. The instructions will always state to solve. So I want to isolate my radical on one side, so I'm going to go ahead and subtract the 6. So I'm going to go ahead and subtract 6 in the left, and I'm going to subtract it on the right. And we're going to get that square root of y minus 5 equals to a value of negative 2. We're thinking, okay, the opposite of the square root, where the index is 2, is to raise both sides to the second power. So we're going to square the left side, and we're going to square the right side. We're going to get the square and the square to cancel, and we're left with y minus 5, and that's going to equal to a value of positive 4. And we're going to add 5 on both sides, and we get y equals to 9 again. Notice I didn't state the domain, but let's go ahead and do it just to show our answer is either correct or not correct. So we know that y minus 5 must be greater than or equal to 0. Adding 5 on both sides, adding 5 on both sides, we're going to state that y must be greater than or equal to a value of 5. Okay, so that's the domain. I see I got y being 9, which is greater than or equal to 5. I'm happy with that. So now we're going to plug in. And we're going to plug in, and we get 9 minus 5 plus 6, and we get the square root of 4 plus 6. And the square root of 4 is 2 plus 6, but 2 plus 6 gives us 8. And notice here, our value should be a value of 4, and therefore we know y does not equal to 9. Y does not equal to 9. So some people might say, is it sufficient to just look at the domain of the problem? No, you must look at the domain, and you also must plug in every single time. So make sure to plug in each one of your answers. And some people ask, well, why didn't it work in this circumstance? And notice here at this step, we had the square root of y minus 5 equals to negative 2. But let's think about that. We know the square root of anything is always going to be a positive value. Otherwise, it's going to be an imaginary value. So we know the square root of anything must always be positive. And here we got the square root to be negative. So that's one of the indicators that you know you're not going to get a solution that will suffice and satisfy this equation. So always make sure to plug in your solutions at the very end to solidify not only the answer you got was correct in the algebra, but also to make sure that it does satisfy the constraints of the problem.